All right, good morning, guys. I am out at the WEC today, so it is December 5th. We are talking about combining polynomials. So here you can see a few different examples. We start with a monomial if we only have one term, and then bi, tri, and anything above 3 we just call a polynomial. So I got to check the shot really quick, and then we'll start the lesson. All right, so we are talking about polynomials here. So the first thing we want to do is talk about monomials. Let's zoom in here a little bit. I'm actually going to pause this and recenter my board. All right, so when we discuss monomials, we first want to talk about the degree of the monomial, or any polynomial. So the degree comes from the combined powers of all variable terms in the monomial. So 5x, we only have one variable here, and the power on that variable is 1. So the degree of that monomial would be 1. In B here, we have two different variable terms. We have a power of 3 and a power of 2, so our combined degree there is a 5th degree monomial. And then in C, all we have is a constant term once this captures, and I can slide over. So C is just 4. We have no variable terms here, so there's no powers on the variable terms, so our degree is just 0, even though that constant value is, to the first power. We're talking about the powers of the variable terms, so there's nothing there. That degree is 0. So try the got it on your own. What is the degree of 8xy? Pause the video if you need a second to think about it. Otherwise, we see that we have a power of 1 on the x, a power of 1 on the y. My degree here would be 2. When we talk about adding and subtracting monomials, you guys are already familiar with this. We just have to apply our like terms rules. So, of course, x squared and x squared, because they have the same variable and the same power, they are like terms. So if I have 3x squares and 5x squared, I really have 8x squared. Same with 4x to the third y minus x to the third y. When we see multiple variables put together, we can really think of this as like x to the third y could equal some new variable z. So really this is like 4z minus a z. So we would end up with 3z, but since z was actually x cubed y, we just write it out just like that. People sometimes get a little scared when we have multiple variables together. Just remember, if it's the same set, then it's the same set. They are like terms. So try the sum here. Pause the video if you need a moment to think about it. We have both x to the 4th, so negative 6x to the 4th, and positive 11x to the 4th. So my positive value is bigger. We say, what's the difference between them? And it's 5x to the 4th. Then what is the difference between 2x squared y to the 4th and 7x squared y to the 4th? Excuse me, so which is bigger? My 7 is larger, so my answer is going to be negative 5x squared y to the 4th. Moving on, we want to classify these. So when we classify polynomials, there's two things we need to talk about. One, how many terms are there? And two, what type of polynomial is it based on its degree? So I'm going to pause the video really quick just to get a drink of coffee. So the first thing we want to do is write the polynomial in standard form, which is kind of your y equals form. You don't have to put y equals, but I do, because when we think about this, we're really working towards graphing it. So to put it in standard form, you want to start with your highest power first. So we would change this to 4x squared plus 3x. Now we want to name it. Obviously, we see we have two terms, so it is a binomial. But what sort of binomial is it? My highest degree here is 2. So that tells me that when I look at the graph, it would be a parabola. So this is a quadratic. Q-U-A-D-R-A-T-I-C. So this is a quadratic binomial. If you look here at option B, we have a highest power of 5x to the 3rd. So when I arrange this, I would put my 5x to the 3rd first. And I can combine my x values. So I have 4x and 7x. So together that is 11x. And then I have a constant of minus 1. So my highest power here is the 3rd power. So that tells me that it is a cubic trinomial, because we have 4 terms. Or sorry, 3 terms. Try for 3. 1, 2, 3. We have a cubic trinomial. Now, I know a couple of you are probably thinking in your head, why do we use quad, the prefix that normally means 4, when we're talking about a power that is squared? We can talk about that in class if you're curious. It is something that I've always thought was kind of interesting. So try this on your own. Put it in the right order to write it in standard form, and then identify it both based off its power and how many terms it has. Pause the video and come back, because I'm about to pause the video. And then the answer will just pop up. So my highest power here is x to the second power, x squared, so that gives me a quadratic. Then I have 3 different terms, so it is a quadratic trinomial. Now we actually get into applying this knowledge. So we can use polynomial expressions to do all sorts of population studies. So here we have some information about campgrounds and backcountry camping. So over a 5-year period, we've collected the data to say that this quadratic trinomial and this quadratic trinomial represent the amount of campers in campgrounds like non-primitive camping, like you got electricity, you got a shower house, and then backcountry camping. So in each polynomial, x equals 0 is the beginning of the data collection, so that would be how many people camped on year 0 or the first year. So it says what polynomial models the total number of overnight stays in both campgrounds and backcountry. What we're going to want to do is combine these polynomials through addition. So I'm going to pause the video so that I can write all this out. So you pause the video also. Combine all like terms in both of these polynomials to create one total polynomial. All right, so when I combine my negative 7.1 and my 21, I get a 13.9 for my x squared. When I combine my negative 180 and my negative 140, I get a negative 320 for my x, and then a constant of 7,700. So in year 0, in that first year, we could say that there were 7,700 campers combined between the two of them. Then we could use this model to predict any year we want, actually. So if we plugged in like x to be 10 or 20, we could predict how many campers there would be in those future years. Go ahead and try the got it. We are going to combine the amount of carrots and celery and broccoli. So we've got these two trinomials down here. We want to say, we want to set up a polynomial to model the total number of pounds in millions of carrots, celery, and broccoli consumed in the U.S. for this 6-year period. So go ahead and pause the video, try that on your own, come back for the solution. I think I misspoke. I think I said that both of these are trinomials. Obviously, this first one here is 4 terms. We just then call it a polynomial. Anything over 3, we stop with the special names. Broccoli, though, started as a trinomial. When we combine those, we're going to get a binomial because there's nothing that can be combined with the negative 12x cubed. So that starts out when we write this in standard form. Then we combine our x squared, forgot the power right here. We combine our x squared values and get 120x squared. We combine our x values, get negative 255x, and our constant values give me 6,022. Now we want to move on to subtracting polynomials, which the only thing to watch out for this is that we have to distribute that subtraction or that opposite to every term in the value beyond that subtraction. So this subtraction is going to distribute to every single term here, making it the opposite as it is now. So if I write this out, my x cubed minus 3x squared plus 5x, none of that changes. But then the opposite of 7x cubed is a negative or a minus 7x cubed. The opposite of a 5x squared is a negative or a minus 5x squared. And the opposite of a negative 12, because remember the sign in front of a term goes with it, that's actually going to be a positive 12. So now when I combine these values together, again taking the like terms, we're going to get negative 6x cubed minus 2x squared plus 5x plus a constant value of 12. Pause the video, try the got it on your own. Do not come back until you have your final solution. All right, so when we take the opposite of all these values, this is going to become a minus 4m squared, a minus m, and a positive 12. So when I combine my 4m cubed, well, there's no other 4m cubed, so I just stay with the negative 4m cubed. No like terms, it just stays the same. Negative m combined with negative m has just the single power. So I look for a single power I have a positive m over here, but it's going to be the opposite of that. So they combine together and give you the negative 2m. But remember, in standard form, we have to order in the correct order based on descending powers. So my 4m squared actually comes before that, but remember, it's the opposite. So it's a negative 4m squared. And then my 9 can combine with what will now become my positive 12 and give me a positive 21. So that wraps the lesson for today. If you have any questions, comments, or concerns, please post on Schoology. Otherwise, go ahead and start on your homework. You should probably be able to get done with your homework in today's class period. Thank you guys for your attention. Have a great rest of your day.